For the second part of this problem, I needed to go and rewrote it so it could have more room. I have sine squared x from 0 to pi around the x-axis. So I'll write it down, the formula. To find the volume of a cylinder, volume is pi r squared h. And that's the exact same thing I'm going to do with this. So I'm going to take the integral from 0 to pi. So I'm going to have pi r. This is going to be my r. This is my line from here because I'm trying to find from the x-axis to this. So it's going to be sine squared x, and that's going to be my r squared, and the h value right here is actually going to be from here to here, how long that cylinder is, and that's what that covers. Now before I could actually do that, not forget my dx, as I stated last video, I cannot do sine squared yet. I can't do that one yet. I can't do sine squared, and I definitely cannot do sine to the fourth. So what I'm going to do is I'm going to use the substitution I used on the previous problem to be able to go ahead and do this one here. So on the previous problem, I was able to go through and say that I know that 2, let me see, cosine sine squared a 2 sine squared a is equal to 1 minus cosine of 2a. So again, divide by 2. Now I should get sine of 2a, sine squared a, sine squared a is equal to 1/2 minus cosine of 2a over 2. So this is one I can take the integral of. I can't do sine squared. So I'm going to substitute this. So I'm going to bring it back over here, but I'm not ready to work on that yet. I need to just take care of the sine squared squared. So I'm going to replace the sine squared on the inside with, I have 1/2 minus cosine of 2, that's x, dang it, I made that same mistake, over 2, and I have to square that. So the sine squared is what I replaced here, and I got with this, and now I have to square. So what I'm going to do is I'm going to, if it's square, I'm going to do some distribution here. So get rid of that and just write it over again so I could actually FOIL my problem here. 2 minus cosine 2x over 2. Okay, so now from here I need to go ahead and do my distribution. So 1/2 times 1/2 is 1/4. 1/2 times this is going to give me negative 1/4 cosine of 2x. Distribute here, and I get minus 1/4 cosine of 2x, and I have two negatives. Negative, negative makes it a positive, and I have cosine. Let's see, that's going to be, so 1/4, and that's cosine squared of 2x. So let's draw a line so we don't confuse this piece right here. Okay, so for this one right here, I have cosine squared again. So let's go ahead. I'm going to factor out that 1/4. I'm going to factor out the 1/4 as I combine my like terms. So I'm going to take it a 1/4, and so I'm going to be left with 1. Now I have right here like terms. So if I take out the 1/4, I have, this was a negative 1/4, negative 1/4. It would have been negative 2/4. So it's going to be a minus 2 cosine 2x. That gives me that and that. And I'd factor out that 1/4. It's going to be plus cosine of 2, cosine squared 2x. Right there. So now I've taken care of the first set So gone through distribution, but now I have another square right here. I cannot do this. I could do this, this, but not this yet. So I could use substitution again. So now my substitution for this next part here is the cosine squared. So my identity for this one says that I have, let's see, 2 cosine squared A is equal to 1 plus cosine of 2A. So if you notice, there's not a 2 there, so I have to divide by 2 to make it match. So I get cosine squared A is equal to 1/2 plus cosine 2A over 2. So this is what I had to do here, so I could actually substitute here. So let's take a look. I'm going to have 1/4 still out here. 1 minus 2 cosine 2x plus, so I'm replacing it. I have 1/2 plus, let me see, that's going to be cosine 2x over 2 right here. Okay, so now from here I'm going to go ahead and I have to combine like terms from this, and this is going to help me out a whole lot. But from here I already had a 2x. So since I had a 2x right here and I plugged this in, when I plug this in here, it's actually twice of what I have in the original. So from this one right here, I had to make sure that this, I had just a single a here, now it's going to be double. Over here, instead of just having x, which I had over here, I doubled it when I did it the first time, and now when I did it this time I have 2x. So I have 2x here, so I need to fix that. So this is going to now be 4x. So 4x right there. My penmanship is terrible. I apologize. I'm sorry. Okay, so now I have 1 minus 2 cosine 2x plus 1/2 plus cosine 4x over 2. So now I could actually go ahead and clean this up a little bit. So as I clean this up, I'm going to come up with, right here, I have 1 plus 1/2 is 3/2. 1/4 on the outside. 3 over 2 and minus 2 cosine of 2x and plus cosine of 4x over 2. Okay, so now I got it to the point. So if you notice, there is no sine squareds, cosine squareds, or any of that. I could actually do the integration of each of these. So if I'm doing the integration of each of these, let's take a look. So I'm going to take the integration, so it's going to be this piece right here. So that's going to be 3/2 x. So 3 over 2x. Okay, so integrate negative cosine. So negative cosine's over here, and that's going to give me a negative sign. So I have negative. Okay, and this one right here, the 2 goes down, so this is going to be over that right there. Forgot to bring that down. Or 4. Okay, goes over, so that one, the 2's will cancel right here, so I get minus cosine of 2. Ah, dang it. Negative sign. Negative sign. 2x. And this one right here, this one's going to go down, so that's going to be over 8. So I get plus positive cosine is going to give me a positive sign. 1/8 sine of 4x, and to there. Okay, let's go ahead and put this back in. So I get 3 over 8x minus 1/4 sine of 2x and plus 1/32 sine of 4x, like that. So we've taken care of the integration part. So just the integration part. So this next part right here, I'm going to go from here. So I have from 0 to pi, and all this right here needs to be multiplied by, because that's all my r squared. I did the derivative of this, and I still am missing my pi from my original problem, which I had up here. Okay, my pi r squared h. So here's my pi r squared, h is here. So now I'm at this point right here. Okay, I did all my integration here. Now I have to do this part, and I have my pi there also. So let's take a look. So I'm going to leave this on the outside. So I'm going to leave this on the outside. So I'm going to go ahead and do my from 0 to pi, and then my answer is multiplied by pi, whatever I get there. So all this right here, so I'm going to leave pi on the outside. So if I'm plugging in pi, this is going to be 3 pi over 8 minus 1/4 sine of 2 pi plus 1/32 sine at 4. This is parentheses pi. So all this right here is this part right here. So I did my pi minus 3 over 8 times 0 minus 1/4 sine 2 times 0 is going to give me 0 plus 1/32 sine of, okay, 4 times 0 is also 0. So let's move this up a little here. So now whatever answer I get here, I'm going to end up multiplying that by pi, because that is from my original problem. So let me see right here. Now, let's bring this down. I have 3 pi over 8 right here, this one. Now the sign at 2 pi is going to be 0. So let's go minus 0 for that piece right there. And at 4 pi it's also going to be 0, so that's minus 0. Okay, so I have that minus, now 3/8 times 0, 0. Sine at 0, 0. Sine at 0, 0. So now together here, I'm going to end up having all this right here goes away. So the only thing I have left is just going to be 3 pi over 8 times pi. So as I multiply that together, it's going to be 3 pi squared over 8 as the volume of my rotation around the x-axis. So let me bring it down. Yes, this was a lot of work. Yes, I apologize for it. I made a typo there and there. Apologize. Sorry. Alright, looking at this next part, 6.4.3. Alright, right here we can't do this because I have a sine 2x times a cosine 3x. I can't do this because there's multiplication in between the two. We don't have the skills for that one yet. So what we are going to do, okay, we are going to change it up a little. So we know that at the beginning of this one right here, I gave you a bunch of identities for addition. So one of them that I gave you was a sine cosine. So it was 2 sine A cosine B is equal to sine of A plus B plus sine of A minus B. Okay, so right here, I don't have 2 sine A cosine B. I don't have that. The 2's missing. So to make this work, I'm going to divide both sides by 2. So whatever I get here, I'm going to end up having it over 2. So I'm going to substitute this. So now let's call A is my 2x and B is my 3x. So I'm going to have sine of 2x plus 3x plus sine of 2x minus 3x. Okay, so I have all that right there, and that's just that piece right there. It's all going to be over 2. So over here I get sine of 5x over 2 plus, that's going to give me sine, it's a negative right here, so it's going to be a negative sine of x. I took out the negative from inside over 2. So I took out the negative, and so from inside you can go out to the front right there. And so from here, I'm going to go ahead and keep working this one out. So I can now do this integral. I can do the integral now because I don't have any multiplication in between there. So this one right here is going to give me, let me see, the integral of sine starts here and it goes this way, so it's negative cosine. So I'm going to end up with a negative cosine of 5x. Now I take care of that right there, so it's going to be 1 over 10. So, because that goes down, and there's already a 2 down there. Now right here, this one's going to be, so negative sign. So let me see, negative sign is down here, so it's going to be a positive cosine, 1/2 cosine of x. And I believe that's it. The only thing I'm missing here is my plus k. Alright, let's take a look at B. So part B right here, we have cosine to the third x. So again, we can't do this because this is cosine times cosine times cosine. So I'm going to rewrite it. Let's rewrite this. So it's going to be cosine x times cosine squared x. Now I have an identity for cosine squared. I do have an identity for cosine squared. So let's bring this over here. So I have cosine x cosine squared x. So what I'm going to do is I'm going to take that cosine squared and let's take a look. I'm going to have 2 cosine squared a, this is from the identity, is equal to 1 plus cosine of 2a. Okay, to get cosine by itself, divide by 2. So cosine squared a is equal to 1/2 plus cosine 2a over 2. So I have those there, and I'm going to replace that here. So I'm going to have cosine x times 1/2 plus, let me see, cosine 2x over 2. So I replaced this right here with my cosine squared. So now what I could do from here is I can multiply those together. So I'm going to distribute. cosine x, if I distribute here, it's going to be over 2, plus, now distribute here, they're different on the inside, so that's not going to be squared. It's going to be a cosine x cosine 2x all over 2. So as I distribute to this one right here, it's all over 2. These. So now right here, I have another identity that I'm going to use for this one. So I have an identity, because there is a multiplication in between those. I can't do those yet. That says 2 cosine A cosine B is equal to, let's see, cosine A minus B, and that's going to be plus cosine A plus B. Okay, now right here, I'm going to go ahead and I'm going to call this one A and this one B. The reason why is because I don't want to end up with a negative on this. So if I were to rewrite this cosine 2x and cosine x, it would give me the same thing. But when I look over here at my identity, if I had the x minus 2x, that would give me a negative. I don't want to deal with that one right now. So if I were to rearrange this as cosine 2x cosine x, okay, the multiplication property, that you could just flip them around. It's same as 3 times 5 is 5 times 3. Same thing. And so I'm going to rearrange it just so I can make this a little bit easier. So I'm going to go cosine x over 2 plus, now over here I'm going to have cosine of, this is 2x minus x plus cosine of 2x plus x. Now, this is already over 2 in the first place. And I substitute it when I substitute it over here, because I didn't have this right here. I divide by 2 because I started off with 2 right here because I needed it to match the cosine. So I needed to divide both sides by 2. So now this one over here is going to become a 4 right there. Because I already have a 2. I'm already dividing by 2 there, and I'm dividing by another 2. So now I'm dividing by 4. Okay, so I get cosine of x over 2. That's going to be plus 1/4 cosine. That's going to be x plus 1/4 cosine of 3x. Okay, so right here, let's look. I can do some combining of like terms because I have cosine x, cosine x. So together, since this is, as a common denominator would be 4, this is 3 over 4 cosine x plus 1 over 4 cosine of 3x. Now after using all those identities, all that jibber jabber, all that other stuff right there, is I could actually do my integral now. So now I no longer have any multiplication in between. I have a single angle, a triple angle, but no multiplication of the two cosines. So I'm good there. dx. So all this work is to try and do this one right here because we don't have the means to do this one yet. So from here, so derivative, or I'm sorry, integral of cosine is going to give me positive sign. So negative 3 over 4. Why did I say negative? It's a positive. Positive 3 over 4 sine x. And again, cosine is going to give me a positive sign. So, but that 3 goes down, so this is going to be plus 1 over 12 cosine 3x. So that's going to be my final answer, except my missing k, constant. Alright, the practice is going to be 1 through 9. The homework is going to be 1b, c, d, g, 2, a, d, g, I, 3ac, 4ab, 5df, 7, and 9. And just to let you know, on a couple of these right here, I believe it starts off at 3. It's a tangent. Now, we know that to do the integral of tangent, it's the same as the antiderivative. So last section, we actually did the derivative of tangent. We got, not derivative of tangent, we had the derivative that gave us a tangent. So go back through your notes and look at it. So we have a derivative that gives us a tangent at the end. And so we work it backwards. So the antiderivative, we start with what we ended with, and we come up with what we have. Okay, that's how we're going to have to do those integrals, because they are the antiderivatives.